Morning, everyone. I'm Mike Greenley. I'm the CEO of MDA. I'm here to talk a little bit this morning about artificial intelligence and how we're using artificial intelligence to push the boundaries of space exploration. I'm going to give you a bit of information about MDA and what we're doing in the world of artificial intelligence, and then I'm going to talk specifically about space exploration and how we're using AI there. MDA is a 51-year-old space company these days, headquartered here in Canada. Proud to be involved in space and the space market in the Canadian sector for the last 50 years. Canada being the third country into space, and MDA having the opportunity to get in on the ground floor and be able to have world-leading positions now in a number of areas in the space market as a result of the experiences that we've gained over the last 50 years. We've had the chance to get some bragging rights, which I've thrown up here on this chart here, looking at building satellite systems and subsystems that have been part of over 300 satellite missions, working on 3 generations of satellite-based radar for Earth observation, working on rovers and other exploratory vehicles that have gone out and poked around other planets. And then, of course, robotics, which has developed into the Canadarm series of products that have been on Space Shuttle and Space Station and now being used into the future. So I'll tell some stories about a bunch of this experience that we've had and where artificial intelligence is fitting in as we go forward into the future. We've organized MDA these days into 3 strong business lines. Each of these business lines is having the opportunity to exercise artificial intelligence in its emerging business. In geointelligence, we're heavily involved in Earth observation. As I mentioned, we've delivered 3 generations now of radar satellites to the Canadian market. We continue to own and operate RadarSat-2. And we're starting to get into some serious thinking about what's the 4th generation of radar satellites going to look like coming out of MDA and coming out of Canada. In the Earth observation business, we get involved in delivering telemetry and data, but increasingly information products that are delivered as an information service based on analytics. Those analytics increasingly are using artificial intelligence and machine learning to be able to conduct analysis of Earth observation data often from multiple sources to create the information products that we deliver to our customers. So we'll see continued expansion of artificial intelligence in that area of our business. In satellite systems, we continue to build satellite subsystems, antennas, electronics, and payloads. Also full satellites when required here in Canada. And we're seeing a transition in that market from analog to digital satellites as we start to get into more software reconfigurable satellites with onboard processing. And as we're doing that, we start to again see the opportunity for artificial intelligence to be applied to the next generation of solutions in the satellite systems business as well. Our 3rd business area, robotics and space operations, has been involved in the delivery of robotics, like I say, Canadarm through Canadarm1 and Canadarm2, and also in rovers and spacecraft for interplanetary exploration. We've had technology on Mars now for over the last 12 or 13 years on the various rovers that have gone there. We're starting to see tremendous opportunities in this space exploration line of our business for the use of artificial intelligence, and that's primarily what I'm going to talk about today. I'll focus the conversation on robotics, on the Canadarm series of projects that we've had, Canadarm1, which was on Space Shuttle, Canadarm2, which is on Space Station, and start to introduce Canadarm3, which will be the new set of robotics that we're delivering to Lunar Gateway, which will be a new space station that will orbit the moon, which will be highly autonomous and make extensive use of artificial intelligence as we move forward into the future. The story begins with Canadarm. That's what started Canada and MDA's experience in robotics on orbit. Canada committed early to be able to provide robotics to the Space Shuttle, and MDA had the opportunity to deliver that technology solution. In terms of the types of activities that robotics was used on the Space Shuttle to be able to conduct the business, as you can imagine, looking at that big cargo bay in the back of Space Shuttle, it was originally designed to be able to manipulate stuff in that cargo bay to, pick up and deploy a satellite, maneuver and install satellites into position, to be able to interact with payloads, to be able to conduct experiments in orbit in the back of the Space Shuttle. In addition, over a longer period of time, to be able to manipulate modules, to be able to deploy and start to assemble the International Space Station. So that's what it was created for. Over time, though, there was other reasons and other opportunities came to be able to use robotics that were discovered throughout operations over the years. We supported over 90 missions with robotics on the space shuttle. At times, astronauts on their extravehicular activity, found the opportunity to use the Canadarm as a solid base to be attached to themselves, to be able to get them into position in hard to reach places and a solid platform to work from. The robotics was also be able to use to start really on-orbit servicing, to be able to service satellites. Very famously, Canadarm was used to be able to repair the Hubble Space Telescope, which was a very high-profile use of robotics in satellite servicing. The Canadarm, in terms of its capabilities, really was an arm. It had all the joints and abilities we would expect to see in an arm. The interesting thing from a control system perspective, as you see in the bottom right of this image, is that it was controlled from the space shuttle, looking out the window or looking at a video screen, operating the controls to be able to operate the Canadarm1 on the space shuttle. So all missions were planned ahead of time. People were trained up, deployed on the space shuttle, and operated the robotics in real time, from the control station in the spacecraft, with support using communications from Earth. The next phase of the journey was Canadarm2 and Dexter. So space shuttle helped bring up some components and start to assemble the space station, and then Canadarm2 got installed on space station and could take over the maneuvering of space station modules and the assembly of the International Station, which it got to kind of build around itself over time. It continued to be able to perform the types of tasks that happened on shuttle, continued to be a stable platform for astronauts to work in hard to reach places. But also, found some new roles with advances in camera systems, got to be used to be able to do inspections around the exterior of the International Space Station, but also get involved in, the docking and undocking of space shuttle as it came up to the station. And then as other spacecraft came up to the space station over the 20 years, we've been in operation on the space station for 20 years now. The arm starts to be used for more and more things. Used for free flyer capture, used for berthing and unberthing of new spacecraft such as Dragon as it started to come up. Also itself be a temporary platform for holding payloads of whatever nature to be able to keep them in place around station. Continue to be used, like I say, as a base for astronauts for extravehicular activity support, but also itself as a robotic system do repair and replacement of failed units around the International Space Station. The diagram on the right kind of shows the complexity of the systems that were delivered with Canadarm2, and then in the bottom right-hand corner, Dexter, which was added several years into the operation to deliver certainly the most dexterous, most advanced robot that's in orbit around the Earth today. And you see all the different elements there in terms of the mobile servicing system that helps move the robotics around, the robotic workstation, which provides on space station control environment, and the robotic interfaces that allow the robotic systems to be able to interact and move around the space station, in addition to interacting with spacecraft that have come up with the appropriate robotic interfaces to be grabbed by Canadarm2. MDA got a chance to provide communications as well for the International Space Station, which helps make all the control systems work, which supported a key evolution in control in this particular station. Started off with on spacecraft or on station operation of the robotics, but then with advances in communication systems, eventually and over time, we're able to operate this system from the ground. And today we operate almost exclusively from the ground with robotic operators working out of Houston or Canadian Space Station control centers, the Canadian Space Agency control centers here in Canada. So we've seen a great evolution over the 20 years as a result of advancements in control systems and communication of moving control and operations of Canadarm2 and Dexter, from the space station to now ground-based control stations. And then over time, we found the opportunities to increasingly automate the sequences of operation in that control station to be able to get more and more automation into the operational sequences. In 2020, sent up some software called MAC, which starts to now introduce automated sequences into the control of Canadarm2 and Dextre on the International Space Station. So the next phase of the station is Lunar Gateway, the new space station that will orbit the moon. This will be a new environment, a new spaceport for human and robotic exploration of the moon, so that as we start to send humans back to the moon, the gateway will be there as part of the operational architecture for those missions. Communications to gateway, though, will be highly limited, and as a result, it will be highly autonomous. Our teams like to joke about the fact, imagine leaving your kids at home for a week with a bunch of tasks and let them just go and do all their tasks and don't even check in for like 5 days and then come back and see how they did. That's what it'll be like operating on Lunar Gateway for our teams, in terms of creating an autonomous control environment where we can give the robotics its tasks and then come back in 4 or 5 days and check in, see how that went, and give the next series of instructions for operations. The gateway will be a fully functional space station. It'll be involved in communications relay, science laboratory. It'll be involved as a logistics depot for operations coming in and off of the moon. And it'll be an astronaut way station for astronauts to stop in at on the way to or the way back from the moon, or eventually as they go further out into the solar system, Gateway can be a way station for that. Canadarm3 will be a busy robotic system. It'll be involved in inspecting and replacing failing equipment on the outer surface, positioning science payloads and manipulating science payloads that are being used to conduct science experiments on the station. It'll be used to load and unload cargo and resupply vehicles that are stopping off at station, and supporting astronaut crew during their spacewalks. It's really interesting to think about how Canadarm1 and 2 were used to support astronauts on their extravehicular activity with humans in the loop controlling that robotic system, or looking out the window or the video screen to support those operations. Now to have autonomous operations of a robotic system supporting crew activity, that's even more interesting to think about as we head forward into the future. Canadarm3 has a number of components. It's going to have 2 manipulators. It's going to have a large arm, a large crane-like arm that we would have seen on Space Shuttle or Space Station. And it'll be used for moving modules around the station for manipulating visiting vehicles. And then it'll have a small dexterous arm, which will be used to handle smaller payloads and use specialized tools for highly dexterous tasks related to maintenance, repair, or other activities. There will also be a relocatable storage element as part of the Canadarm3 system that will be used outside the vehicle for storing tools and other equipment. As we get ready for this phase of the journey, it's interesting to think about how autonomy has changed over time, or how our control of the robotics has changed over time or will change further into the future. Canadarm, like we said, on Space Shuttle, looking out the window or at the video screen by an astronaut on the spacecraft, controlling the robotics. Canadarm2 living a 20-year evolution from control on the space station to control from ground now, to now releasing software that automates a series of those sequences. That's sort of our last 30 years. The next 15 to 20 years, looking forward, Canadarm3 on Lunar Gateway will be these once every 5-day type communication windows, in terms of maybe only having up to as little as 8 hours a week of communication time to be able to talk to the robotic system. And then it's otherwise autonomously out conducting its tasks and being able to do all of its activity, maintain itself, and do all of that under the trust of an AI-based control system, which will surely be extensible and upgradable over time as we live through the next 15 or 20 years. To accomplish this, NASA's taken the lead role by designing a distributed architecture for the autonomous management of the gateway itself. MDA's external robotics system will be an agent within that overall autonomous architecture, within that hierarchy, providing high-level information on the robotic state, its faults, and its functional capabilities to that top-level space station agent, and responding to equally abstract goal-oriented task requests from that agent. We'll use a combination of domain-independent and domain-specific AI planners to decompose command goals into a grounded set of actions for the robotic system to perform. We expect to use convolutional neural networks to visually assess if it is safe to approach and manipulate robotic interfaces. And then recurrent networks and reinforcement learning may be used to detect anomalies and prioritize health-relevant telemetry for downlink, since bandwidth to Earth will be a precious resource shared by the entire vehicle. So the ability to perform goal-driven end-to-end robotic operations without human supervision is an essential enabling technology that will start to allow humanity to explore further into the solar system. We will get to develop and prove all these technologies on Lunar Gateway as we live through the next 15 to 20 years, like I say, as we use Gateway to be able to support operations on the moon, and then, like I say, operations further out into the solar system. To be able to do this, MDA will lead a team of largely Canadian companies to be able to pull together this system, pull together and integrate the artificial intelligence control system, which I've just described, to be able to perform these autonomous operations 400,000 kilometers away. And as I said, 15 years is a long time for operations, so I would expect that we would see a persistent business in this area to continually learn from our operations, learn from the autonomous operations at that distance, and continually upgrade and enhance the capability that will be operating in Canadarm3 on Lunar Gateway at the moon. Thanks for the time to be able to talk about this today and tell you a little bit of the story of our evolution and where artificial intelligence is going to let us push some boundaries moving forward into the future. I hope you have a great rest of conference and good interactive sessions as we move virtually through this particular event. Thanks a lot.